Hello everyone. Why AI can't read unlimited text? Attention complexity explained. When you interact with an AI system, it almost feels magical. You paste a paragraph, sometimes even full article or a long document, and the model seems to understand everything instantly. It summarizes it, explains it, and even answers questions about it. But behind this impressive capability, there is a hard technical limit. AI models cannot read unlimited text. Every model operates within something called a context window. The context window defines how much text the model can actually see at once. So the big question is, how much text can a model truly process at one time? And more importantly, why can't we simply make the limit infinite? To understand that, we need to look at how attention works inside a transformer. Attention connects everything. Inside a transformer model, attention is the mechanism that allows words to understand each other. Every token in a sentence looks at other tokens and asks, which of these words matter to me? Imagine a sentence with just 5 tokens. Token 1 compares itself with token 2, 3, 4, and 5. Token 2 compares itself with tokens 1, 3, 4, and 5. Token 3 compares itself with tokens 1, 2, 4, and 5. And this continues for every token. In other words, every token looks at every other token. This is incredibly powerful because it allows the model to capture relationships across the entire sentence. This is how AI understands context, grammar, references, and meaning. But this powerful mechanism comes with a hidden cost. Hidden cost, attention complexity. Let's look at what happens as the number of tokens grows. If you have just 10 tokens, the model performs about 100 comparisons. With 100 tokens, that jumps to 10,000 comparisons. And with 1,000 tokens, the model performs 1 million relationships. The number of comparisons grow extremely fast. This growth pattern is called O of n squared or quadratic complexity. What that means in a simple term is when the input size doubles, the amount of computation doesn't just double, it becomes 4 times larger. So the more text we give the model, the computational cost grows dramatically. And that is where the challenge begins. The context window is limited because attention compares every token with every other token. Extremely long inputs become very expensive to compute. This is why AI models define a maximum limit known as the context window. The context window is simply the maximum number of tokens the model can process at once. Earlier models had very small context windows. Some early systems could only handle around 2000 tokens. Later models expanded this to 8000 tokens. Today, more advanced models support 32,000, 64,000, or even 128,000 tokens. But the principle remains the same. Anything outside the context window is invisible to the model. The model literally cannot see it, which means its understanding is limited to what fits inside that window. 128K tokens is a big deal. So why is everyone excited about larger context windows? Because they unlock entirely new capabilities. With a larger context window, models can process long documents, entire conversations, large code bases, and even full research papers. For example, a context window of around 128,000 tokens is roughly equivalent to 300 pages of text. That means a model can analyze and reason over a massive amount of information at once. But increasing the context window is extremely challenging because the attention mechanism still follows that quadratic cost curve. More tokens mean exponentially more relationships to compute. That's why researchers are constantly working on more efficient attention mechanisms that can scale better. And solving this challenge is one of the biggest frontiers in modern AI research. So, what's next? If you have been following along so far, you're now starting to see how the pieces fit together. From tokens to embeddings to attention to transformer layers and now the limits created by attention complexity. This is exactly why we created the AI for Beginners course to explain these powerful concepts in a way that is clear, intuitive, and easy to understand. If you want to build a strong foundation in modern AI, I highly encourage you to go through the full course. And if you find these explanations helpful, make sure to subscribe to the channel because we break down complex AI topics step by step so that anyone can understand them. In the next part of this series, we will move beyond how models work internally and start exploring how we actually build real world AI systems. We will cover the limitations of LLMs, how systems use retrieval augmented generation or RAG, how models can be improved using fine tuning, how they interact with external tools, how AI agents are built, and how modern systems are starting to connect everything together using model context protocol. So stay tuned because the next part of this journey is where AI moves from understanding language to actually performing real world tasks. See you next time. Until then, take care.